Yes, we can hear you fine.
Okay, perfect. So welcome everybody to this webinar. So this is me. I'm the one on the left. I'm Diego, and I was one of the current founders and one of the current maintainers. And I'm going to give this webinar that when I checked yesterday, I saw that there were no previous requirements to join this webinar. So the first thing I'm going to do is I'm going to review the full process of creating a package from an existing code, then how to upload this package to Artifactory, the server, to be reused by other projects, and how to automate this package creation process with Jenkins CI. Then I will slide to some more advanced topics like testing and how to create package tools, for example, a compiler or CMake, put them in a Conan package so that it can be reused in your flow. So let's start. I'm going to first explain how to create packages from existing code. So here I have a library. It's a very simple library. It's just a hello world. I can see here the declaration of the function. The function is just putting something to a standard output, two different messages depending on release or debug, but it's just a hello function. Building this library is done with CMake. In this case, I'm using CMake as an example. I can use any build system because I can create packages created with any build system. We have very good integration with CMake and Visual Studio and Makefiles, but you can use any. So basically, the build script I have here for my library is just defining a static library from this hello.cpp file. And this is basically what it does. So to create packages, I'm using what is called Conan recipes. Conan recipes are Python scripts that define how to build and to create that package. So this is a full recipe. It's a working recipe I'm going to use to create these packages. So the first thing I would like to highlight here is this line. The settings declaration is defining the things that affect my binary. If I change my operating system or my compiler or my build time or my architecture, I will have a different binary. So this is something I need to declare to build the model of the binary compatibility for Conan. Then I will have here three methods. The first one is the build one. It's the method that is telling how to create this package from sources. In this case, I'm using the CMake build helper, but you can very well use anyone, just as long as you call your build system from this build method, it will be enough. So in this case, it's simple because I have the build helper. Then once the library is built, I have the package method. The package method is telling which artifacts build the final package. In this case, and a very typical case, of course, is the headers. I want to package the headers and put them in an include directory. I want also to package the libraries, both the static libraries for Visual and GCC, because I'm going to use both. So I want to package also the binaries. And finally, I have the method that is called package-info. The package-info method is instructing the consumers, the users of this package, that they need to link with the hello library. In this way, the consumers, they don't have to figure out what the include directories, the library names they have to use, because most of it will be automatically defined. So this is everything I need to create a package for my source code in this library. And I'm going to show you that doing the Conan create will fire this package creation process. So here my build method will be called. It will be calling CMake, and it will start building the library. Right now, it is using my default configuration. My default configuration is, I'm on Windows right now, so it's Visual Studio 15 release 64 bits. So if I check what I have in my local cache, this is everything local to my machine, I can check that I have exactly one binary for this hello package. I have one binary built for 64 bits, release, Visual Studio, whatever. I can repeat this process as many times as I want. Conan create, user testing. In this case, for example, I can specify that I want to create a debug package because I want to be able to build in debug mode. So I will repeat the process specifying that I want to create a package for the build type debug. So I can repeat this for changing the compiler version, the architecture, and what I will have some different binaries here in my local cache. This would be the one for release, and this would be the one for debug. So this is the package creation process. What I have is basically this. Everything has been built in my machine, in my local cache. And starting from the recipe, I have built 2 binaries. Okay. So now the logical process is, okay, these 2 packages here are good, they are useful, and I want to share them with my team. So I want to put them somewhere so my team can use them without requiring to build from sources again. Because if this library actually is small, but if the library is big, then they will spend a lot of time, they will waste a lot of time rebuilding again and again from sources. So I want to upload my binaries to somewhere so my team, they can reuse them. By the way, this is a very short description of how the binaries are identified. So basically, you take all the inputs, the configuration, for example, the settings, the operating system, the architecture, the compiler, and you has everything. The Conan has everything, and it constructs the package ID. The package ID is basically the SHA-1 hash of the settings, let's say, put in so. So when I was doing here in the Conan search, I had 2 different binaries, each one identified with a hash. This hash is basically the hash of this information here. So every time you change the configuration, you change the settings, you have a different hash and you have a different binary. So I want to put these 2 binaries here somewhere. So I have several options here. I have an open source free Conan server that is included in the Conan installation itself, so it's ready to use, it's documented, but I'm going to use JFrog Artifactory that is more powerful, and indeed it has a web UI, so it is more convenient for this demo, and of course it scales much better than it has advanced control of authentication permissions. So for productions, the Artifactory is definitely the way to go. So I'm going to upload my binaries created in the client to Artifactory. So here I'm going to do, the first step will be create a repository. So, yeah, sorry, I have to log in. Okay, so I'm going to create a repository, new repository. I'm going to select the Conan repository type, and I'm going to give it a name. Let's say, okay, so now I have my repository. I could navigate it. Of course, it is empty. To configure my Conan client, I have a button here. It's called the Set Me Up. In the Set Me Up, I will get the URL of this repository, and I can use in my Conan client. So Conan comes with a remote pre-configured that is the Conan Center, is the public central repository for open source packages that it is hosted in Bintray. So what I'm going to do now is I'm going to add a remote. I'm going to call it Artifactory, and this is the location of this remote. And this is basically it. It works basically the same as Git. It has the same model. You can have as many remotes as you want. So now what I want is to upload these binaries. I want to upload all the binaries that I created locally, and I want to upload them to Artifactory. Yes, I do. Okay, it is uploading the file, so I'm going to check my Artifactory. And here I can see that I have my two packages. Okay, and the two types for release and debug, they are both here. Okay, this is how I create packages and put them in Artifactory, so my team can use them. So for the people that are not very aware of how Conan works, I'm going to show actually how you can consume these binaries, how can you use them. So here I have a small project. This small project is just a main application that is calling the hello function. So it will need to link with the hello library. And for this, I'm going to use this simple conan file.txt file. It's everything I need to make sure that I am actually retrieving from Artifactory. I'm going to remove my local package here. Okay, so I'm going to, this is my application. So first I'm going to install my dependencies as declared by my conan5.txt file. So I'm doing it in a temporary folder. I don't want to clutter with temporary build files. So the first thing I'm going to do is to install my dependencies. Here I can see that they are being retrieved from Artifactory and they are being downloaded. Okay. So actually what Conan has done for me is this. It has installed the dependencies and it has generated a file that is called conan-buildinfo.cmake file. Depending on your build system, it will generate a different file. If you are using Visual Studio, it will generate a properties file that you can use in Visual Studio, for example. So this file here, the conan-buildinfo.cmake file, is the one that I can very easily use in my CMake list script like this. I will just include the file, the generated file. I will call something like Conan basic setup, and I can link with my libraries. It's basic CMake stuff. So from now, it is just regular CMake or your build system stuff. In this case, I'm building my consumer application with Visual Studio 15, 64 bits too. This would generate the Visual Studio solution. I could open the IDE and I could work from the IDE from now, but I'm going, as this is a webinar, I prefer to run on the command line. So I'm going to build with Visual Studio. I'm building with Visual Studio right now, just in the command line. And here is my example application that is linking and is reusing the hello package that we just created and uploaded to Artifactory. So this will be the whole cycle from the moment we create a package, we put it in Artifactory, and the consumers, other developers, they are consuming this package for their applications. So now what we typically want to do is we want to automate. We want to automate the package creation process. So,
Diego, sorry to interrupt. Before we go on, maybe the two of the questions that we have fit nicely in this introduction. Do you want to look at them now, or do you prefer to go back to this at the end of the webinar? So we have one.
I see two. Yeah, I see two questions right now. They are not. I think we can delay them until the end of the question because they are not closely related to the package creation process.
Mm-hmm. So, okay, good. Let's go back to this at the end of the webinar. And again, for anybody else, just please type your questions in there and we will leave some time at the end. Thank you. Sorry for the interruption, Diego.
No problem. Okay, so Then the next natural step is to try to automate in, and I'm going to use Jenkins. Typically, you want to do something like this. You want to have several slaves, several build slaves that will create different architectures, for example, in Windows and Linux. And all of them, they will be putting the binaries, uploading the binaries automatically to Artifactory. So to automate the package creation process, the way that I would recommend will be this. First, Jenkins can be configured on the web UI, and you can put scripts there. But you can also add a file in your repo that is the file that will be used for firing Jenkins. And of course, this is my preferred way to do it, because you can you will have the Jenkins file in version control. That is much nicer to do changes and to maintain it. So the first step is to add a Jenkins file in the root of the repository, and this would be the one simple Jenkins file that we can use to automate the package creation process in Jenkins. The first thing that we have to note is that there is some custom syntax here. So we have the Artifactory.server here in the second line. We have the Artifactory new Conan client. So this syntax here is not a regular Jenkins pipeline syntax. It comes from an Artifactory Jenkins plugin. So if you install the Artifactory Jenkins plugin, then you will have this syntax. So otherwise, if you don't do it, you can still use Jenkins with Conan. Just it requires a few more lines, because it will not have the terse syntax that the plugin provides. But it still it is possible. It's absolutely possible to do it without it. So this is the pipeline that I'm going to use. It's a very simple one. The first step is just to check out from source control. This is regular pipeline syntax. There is nothing related to Conan here. Just getting the repo, cloning the repo, and getting the sources. Then the second stage of my pipeline is to create a package. It's basically what I've done in the command line. Jenkins will be doing it for me. So it will be firing the create of the package, and finally, when the package is created, it will upload the package to Artifactory. So exactly the same as I did in command line. After building, Jenkins will be able to push things to Artifactory. Of course, Jenkins is very powerful. I'm just showing very little of its power here. So one of the things that we could do is we could build several configurations in parallel. So for example, in the command line, previously I built debug and release configurations. In this case, I'm going to build in parallel both 32 and 64 bits architecture for the hello package. And they actually will be running parallel. And if you have further slaves, you can go wildly parallel if you want. So this is basically what you need to run a Jenkins. Let me show you. So what I've done here is I've added to my repo this Jenkins file. Here you can see this is exactly the syntax I've shown you in the slides. And there are two nodes. There is one node for 32 bits, and there will be another node for 64 bits. Of course, the node for 32 bits will be specifying to use the architecture for x86, and the node for 64 bits will be specifying the architecture for 64 bits in this line here. Okay, so then I need to I'm going to add the Jenkins file to version control. I'm going to make sure that that you clearly see, I'm going to clear my Artifactory repository. So now it's absolutely empty. And I'm going to configure a pipeline in Jenkins. So I'm going to call it hello. This would be a pipeline. And in the simple case, what I have to do is just configure from the version control. Version control is going to be Git, and I need to enter the Git repo. And we are done. Of course, typically you will implement some hooks. So when you are pushing changes to the repo, it will automatically fire the Jenkins build. In this case, I'm just firing it manually, but basically the process is exactly the same. It will just fire this pipeline. You can see it is working in parallel. So we have a couple of created packages in parallel. Yeah, it takes some seconds to build. Yeah, and now it is uploading the packages, and everything looks good. So I'm going to check, and it happens that of course, I have my 2 package binaries, one for 32 bits in Artifactory, and the other one for the 64 bits, as they have been built in parallel in Jenkins. So this will be the basic automated process for creating packages with Jenkins. So in summary, is something like this. You do some changes to your source repo. You push them to Git. Git fires Jenkins job. Jenkins job will be building the packages and then uploading the packages to Artifactory. But in the general case, it could be a bit more complex, because what happens if your package, it has dependencies. So if the package that you're building, it has dependencies, those dependencies, they will be hosted in Artifactory too. Artifactory will be used as the ground truth for your binaries. So if you're building a library that depends on another one, and you don't want to rebuild the dependency, you just retrieve the dependencies from Artifactory. You install them in your Jenkins slave, you build the dependency graph, and then you generate the conan-buildinfo.cmake or the respective file for your build system from the information of those dependencies. Then this information of the dependencies, the binaries that have been retrieved, is injected in the current project build system to build the source code. And this will generate binaries for this new project, for this new package. So finally, the latest step is, okay, we are done. Now we are going to publish, we are going to upload these binaries to Artifactory 2. So in case someone else needs them, let's say another developer or maybe another continuous integration job that is going to use these binaries too, they can fetch them from Artifactory and they can use them without needing to rebuild them from sources. Okay, so this is the basics with a very simple Hello World library that we are using. But we want to add more. We want to, for example, what happens with our unit testing? Where could we do our unit testing of our library? How to manage that? How to file that? How can we integrate it? And what happens with package testing? There is a different level of testing. So I'm going to show you how could you manage this with Conan. So, well, yes, I'm going to stop. There are a few other questions. Yeah, some of them might be relevant. So Okay, there is a question that says, does or will Conan have generator support for Eclipse CDT at some time? This is a very good question. We have tried, and we have tried to use Eclipse CDT projects, but there is some limitation to them. Is that Eclipse doesn't have a way to inject information. So let's say that you have your include directories, library names. You have an even compiler's flag from your dependencies, and you want to tell Eclipse CDT, hey, this is this information for your dependencies. You cannot do it. You are forced to do it in the .c project file at live, and you cannot provide it as a separate file. That will be the clean way. So there is no current clean way to do that. I've heard that the Eclipse CDT, they were moving in that direction, and they were going to provide something, but it's still not possible. So at the moment, it's not possible. Otherwise, could we get the Yuri to download this presentation? Yes, I have no problem. I can share the slides and the code after the presentation. No problem. Another relevant question here is the Artifactory new Conan client step fails if the job is being run in a Docker container. Might be. Up to my knowledge, this Jenkins Artifactory plugin and the syntax for Conan is prepared for native. Let's say in the machine build, but probably not for Docker. So probably is something that needs to be provided by the plugin itself. It's not something we can fix in Conan, but in the Artifactory Jenkins plugin, it would be a good feature request to provide this feature here. Okay, so I'm going to. I was going to show how to integrate, how to use testing, unit testing in my package. So the first thing, what I'm going to do is to add a file that I'm going to call test CPP, and this file here, I'm going to add a couple of unit tests of my library. In this case, my library is just a hello function. I'm just going to call it. But what I'm going to do is I'm going to use the catch testing framework. It's a very popular one nowadays. So I'm going to use this framework. So the first thing, I'm going to add my test CPP file with my test here. Then, of course, I need to tell my build system to build the test. So far, nothing special to Conan here. So it's just my test and my build system. So what Conan can do for me to integrate these things. So the first thing is, okay, so I have now I need catch. Okay, great. Conan is a package and dependency manager. It is able to retrieve catch, of course. It can do. I'm going to. So I have a package here for catch. This package is actually in Conan Center. Oh, sorry. Hold on. Yeah, this package is in Conan Center, so it's a public package you can also retrieve and use. So what I'm going to specify here is that my hello package, it has a dependency. It has a build requirement to catch. Okay. So this will manage to retrieve and install catch in my computer. So my test will link, and my CMake will be able to link with this catch framework. Okay, so this is everything I need to retrieve and install catch, so I can use it. And of course, okay, so I can build the test now, but who is going to run the test? In this case, I could recommend to do this. You can, as the latest step in your build method of your recipe, you add the running the test. Let's see how this works. So I'm going to create this package now. Here we can see that we have a requirement to catch. It is building my package. Now it is building the test. Yeah, it takes a while. Catch is header only, and here we can see that finally we are running the two tests, and everything looks good. So the interesting point here is what happens and why I want to run the test here in my build method. Because if I repeat the process, what happens is that build is running the test. The test will fail. So the package creation process will be stopped, and you will not have a package at all. So it will basically interrupt the process, and you will have to check what is happening. So you are not creating a package that is bad by definition, because it is not passing the test. And here we can see that the test is not passing, the test is failed, so the package creation process has been stopped, and it's not creating the package at all. I'm going to okay. Perfect. So now we have seen build requirement, and I would like to introduce a different type of build requirement. Let's say that now I want to build my package with GCC and min-GW, and it happens that I have GCC 4.9 in my computer. So I could very well try conan-create user testing, and I could try, okay, so my compiler now is GCC, my compiler version is 4.9, my standard. So I could define some settings that will define my current compiler not to be the default Visual Studio, but GCC in this case. Okay, so if I fire this, it will fail. The first reason it fails is because catch requires C++11, and this is not enabled by default. So I want to upgrade. I want to do something a bit more modern, and I would like to use GCC 7 in my computer. But hey, let's not disrupt my current GCC, that is 4.9. I don't want to remove it because I'm using it for different projects, and I don't want to get rid of my GCC 4.9. So what Conan can do for me is this thing. So the first step would be to use a profile. So I'm going to show you a profile here. It's just a text file like this one. So if you remember the settings that I was entering in the command line, instead of typing them again and again in the command line, I can use a profile that is this text file, and I can provide this text file as input to my conan-create command. Okay. So in this profile, I can specify also build requires. It's the same concept as I used here for catch, but in this case, I want to specify it in my profile. So I'm going to specify that I have a dependency to min-GW and now that I have my profile here defined, I can Conan create user testing with my profile is GCC 7. And I will pass the the file. So here you can see that now I'm using, as a compiler, I'm using GCC 7.3. That is the one that I have declared in my profile. It is building my library. It is building the test. And hopefully it will be running the test in a couple of seconds. Yeah, and here we go. Here we have the test, running the test, and creating the package. So this is great, because now I've created a package for the hello library for GCC 7. And the good thing is that I haven't modified my environment. So my default GCC in the system is GCC 4.9, and I haven't changed that. Actually, I can extend the process. You can check that my CMake system version is 3.7. Let's say that I want to use for my profile, for my project, I want to use something more modern, and I want to use CMake 3.9.0, for example. So I can declare that as a build requirement too. So now, by the way, I have here in my CMake list, I have a message that is printing my CMake version to check. So if we go up here, we will see that previously I was using CMake 3.7. That was my system one. So now, if I do the conan create again, and I'm using CMake as a build requirement, here I can see my requirements for building are both CMake 3.9 and BinGW. So I will be using GCC 7.3. And here we see that we have the CMake version 3.9. So this package is actually using CMake 3.9 to build. Okay, I've stopped it without modifying also my system-wide scene. So this is pretty useful. So there is an interesting question here. It's about build requires. So the first thing I would like to highlight about build requirements is that they do not affect the package ID. Normal requirements do. If you depend on a library, another library, and that library change, you will have a different binary. So your dependencies, your normal dependencies, they affect your binary ID. But build requirements, they do not. If you change, you upgrade CMake 3.7 to 3.8, the final binary should be the same, as long as the CMake list works. The build requirements, they are only retrieved and used if it is necessary to build from sources. If you're just installing pre-built dependencies, the build requirements will not be fetched at all. You won't need to install and download them. They can have transitive dependencies. They can be conditional. For example, some very cool example that we have in OpenSSL. In this case, OpenSSL to build in Windows, it's pretty a challenge because it requires both Perl and native assembler. That is nothing that you will typically find in your Windows machine. So the OpenSSL recipe, it has requirements, build requirements, conditionally for Windows for those both native assembler and Strawberry Perl, and it allows to build in Windows relatively easily because everything is automated with build requirements. So what is the difference between this mode that I was adding a requirement in the recipe itself and adding a requirement in the profile. So I would summarize like this. You add build requirements to profiles when they are tools that you could be system-wide. For example, CMake or MinGW, they are actually things that you typically expect the developer to have them. I mean, if you are developing for GCC 7, it's typical that the developer will have GCC 7 in the system. It's not that they absolutely depend on Conan to retrieve it. So in this way, if you put CMake or MinGW in the profile, you allow the developer to do whatever they want. They can use their system CMake, or they can use the CMake from Conan, but it's not a hard-coded. If you put CMake as a build requirements in the recipe, it will always be used by the recipe. And say, hey, I already have a CMake installed in my machine. Why this recipe is fetching CMake to build again? It's not necessary. And another reason that you want to put build requirements in the profile is to be able to switch on and off certain dependencies. For example, if you want to, the testing framework I'm using, you want to be able to run the test or not run the test. And which build requirements will you add to a recipe? I would add to the recipe things that are very specific for that recipe, for that package. Like, for example, testing framework, that you are just using this package, or a build helper, something you need to build, let's say, a code generator, for example. You can add that in your build requirements for a recipe. So what I was suggesting here is, okay, what happens if I take my build requirement from catch, from the recipe, and I put it here in the profile? Everything still works, but now my recipe is a bit more fragile, because if it happens that the profile doesn't declare catch, my recipe will fail, because it won't be able to link against catch. Okay, so if you don't want that, then you can easily manage. How? You can know if you have catch as a requirement or not. You can do this. Hey, testing. If catch is in my dependencies, then I will have test. I can tell my build system with a define to use them or not. So basically, my CMake list, I will be doing this. I will use a define to build the test or not build the test. And finally, I will be able to use, I would only run the test if I have catch as a build requirement. Now, with this infrastructure, I can perfectly say, hey, I'm not going to build the test because I'm just a user. I want the library to be created as fast as possible. Oh, sorry, I need to tell that the profile is GCC. So in this case, my build requirements will be just CMake and MinGW, but not catch. And it will be using GCC 7.3, and it will be using CMake. But in this case, it won't build the test, and it won't run the test. So then you have the power from the end user to say, hey, I want to use this for my dependencies, or I don't want them. So that, of course, that is the policy you want to use for your team. Typically, I will run the test, the unit test, for always. So I'm saying that I will typically have this, and building and running the test will be compulsory for my package creation process. But just in case you want to opt in, opt out of this feature, you can easily do. So these are the tests that they check the library before creating the package. But what happens if you are actually doing something wrong here? Let's say that you forget to copy the headers, or you forget to copy the libraries, or something just went wrong with your build and you did a mistake. You are telling that you are building for 64 bits and actually you are building for 32 bits because there is a bug in your build scripts. So something can wrong with the package itself. So Conan provides a different level of testing that is called the test package. The test package is, do you remember the consumer project that we were using in the first example? Then you can basically put that that project. The consumer project is just a simple application. You can put them in a folder that is called test package. If you add a test package folder close to your recipe, the moment that you do the conan create, then it will first build the package, run the unit test of the package, call the package method and create, sorry. Something went wrong. Let me check. Oh yeah, I forgot to remove the conditional of my build script. So as I was telling, the process is you build the library, then you build the unit test, you run the unit test, you create the package, and once the package is built, here it is building the test, it will run the test. And now we can see that it is building this consumer project. Okay, that is the test package project. It is building it, and it will be actually launching the final application. In this way, you guarantee that the headers are being packaged, the libraries are being packaged, that the consumer application is able to link with the libraries. And let's say that like 90% of the problems and mistakes that you can do while packaging, they are catched by this test package functionality. Okay, so I wanted to end this webinar with showing how to create packages for tools, because I've been using both CMake and MinGW installers. They are also Conan recipes that they are, let's say, average size, because they are managing many different configurations. But packaging your own tool is very simple. I'm going to show you. I have here an example. So I have two things here. I have a file, it's called example. I can run it. It's just the binary that I built. So this is a very simple tool. Okay, and this is the recipe I need to create a package with it. So just the package method to specify what I want to put in the package, and then the package information method. So I let my consumers know where is the binary folder, where they can. This is basically adding the binary folder to the path, so it can be easily used. So this is the recipe I need to create a tool package from a binary that I already have. I can just call Conan export package. And this is it. Now I have a tool here. It's called this. I can upload to Artifactory. And this tool is ready to be used. So I can very well remove from my local cache. Yes, yes, I want to remove them. I'm going to go one level up, and I could Conan install my tool, and I can, for example, say, hey, I want to be able to run directly this tool. I'm going to use the virtual run environment generator that is creating some scripts for me. These scripts, I can use them. So I can, if I try to run the example, sorry, it won't be there, but I can activate my environment, and my application that I installed for my Hello tool package will be there. Of course, I can deactivate. An example won't be there anymore. So this package, this Hello tool package that I've just created, is a package that you can perfectly use in your recipes. It can be a build requirement. You declare a Hello tool 01 as a build requirement of your recipe, and the example application, it will be there. So you can use it in your build method, in your package method. It's something that you can use in your recipes too. Okay, so to summarize, I would like to say that to compare the unit test versus the test package functionality. As I said, unit test is the typical testing framework you do in the build process, and it's the complete unit and functional testing of your library. If the test doesn't pass, then the package is not created at all. And then we have the test package functionality that is not using a testing framework. It's just a basic consumer application put in a separate folder that it basically checks that the package is correctly formed, that the headers have been packaged, the library have been packaged, and it can link with the package. It can do some basic operation. Finally, to close the perspective of reproducibility, because finally we have been talking about testing, about how to reuse tools like compilers or CMake as Conan package. Basically, the goal of all of this is to improve reproducibility. There is a piece, something else we need to improve this reproducibility is, hey, Diego, you have created a GCC 7 profile with some configuration there. What happens if I want all my team to use the same file? And I want all my team to use the same file, not just for the Hello package, but all the packages, they need to use this profile. And actually, I'm not using just one profile because I need to support 4 different platforms. So I will have 4 profiles, one for each platform. And I want all my users for all my packages to use those profiles. And by the way, you will have also configured Artifactory, and you have configured the address of Artifactory in your client. I want to make sure that all my developers, they also, not only my developers, but my developers and my continuous integration machines, all of them, they use the profiles, and they also use exactly the same remotes that you did. How can you do that? And of course, for example, I don't want my continuous integration to be using Conan Center, the public repository. I want just to make sure that my continuous integration is using just my private repository. Okay. So the solution to achieve reproducibility with this is the conan-config-install command. The conan-config-install is a repo. It can be a Git repo, or it can be a zip file. And in that zip file or repo, you put several files. You put your profiles, you put a remotes.txt file, and you can put other files. And then the users, all they have to do is conan-config-install, provide the address of this repo, and then they will synchronize. They will match their configuration to the provided configuration. So this is very simple to synchronize your team of developers to use the same settings. Yeah, I'm going to skip this because I think we are already very late, and I would like to answer some questions. My final suggestion: we are having in SwampUp is a conference that will be held in May in Napa in a gorgeous location. It's a very nice venue. The event is amazing. So this year in SwampUp we are going to have a lot of Conan activities. We will have a Conan training that is a hands-on lab. That you will be able to play with all these things. We will be there. We will be there imparting teaching the lab. We will also have some workshops. We will be discussing Conan roadmap features. We will Conanizing libs, third-party libs, and we will have a dedicated Conan track. And the amazing thing is not by us. It will be given by experts from companies that they are using Conan in production. They are doing amazing things like cross-building. They are doing C++ for mobile. Great things with continuous integration. So I think it is very interesting conference for Conan users. So I encourage you to register and join us because it will be an amazing day. So said that, we are a bit, but I think we can. I can try to answer some questions. So here is a question about can we increase the Artifactory session timeout? I think so. I don't know by heart. Probably we can respond later with some more Artifactory expert. But I don't know. Another relevant, I don't know by heart, so I need to check. So how do you promote a Conan package in Artifactory to a different channel? This actually is a very good question because promoting is a very